64 seconds that could have changed everything. The MSAW rescue mission after Korean Air 801. On August 6, 1997, Korean Air Flight 801, a Boeing 747-300 carrying 254 people, never made it to the runway. In the dead of night, in driving rain and embedded thunderstorms, the aircraft descended toward Antonio B. Juan Pat International Airport. Just 3 miles short, it struck Nimitz Hill. 228 people died. 26 survived, most with severe injuries. The approach should have been manageable. It was a standard non-precision procedure. The crew knew the ILS glide slope was out of service. But in the cockpit, small errors started stacking up. The DME offset was set to 0 instead of the required 2.8 miles. That mattered because the DME itself was located 2.8 miles short of the runway, not at the threshold. It was a subtle error with catastrophic consequences. A stray signal was mistaken for a working glide slope. The crew descended, step by step, below safe altitudes, not fully realizing how far off they'd drifted. By the time the DME said they were at the threshold, they were actually 2.8 miles short and too low to do anything about it. There was no time left to recover. The NTSB would later cite pilot error as the probable cause: fatigue, poor monitoring, and a cockpit culture that made it difficult for junior crew members to speak up. But that wasn't the whole story. Investigators also found a critical gap on the ground, a hidden weakness in the safety net that existed precisely to catch this kind of descent. A system that should have spoken up sooner. It didn't, and 228 lives were lost in the silence. That gap was the Minimum Safe Altitude Warning System, MSAW, inside the radar automation at Guam's CRAP. MSAW was never meant to replace pilot judgment. It was a last resort safety net. It compared live radar tracks against a digital terrain map, and if an aircraft dropped below safe altitude, or was projected to, it triggered a visual alert and an audible tone for the controller. Properly set up, it should have fired 64 seconds before impact. More than enough time for a radio call that might have changed everything. Instead, the system had been quietly broken years before the crash. A local specialist, overwhelmed by nuisance alarms, had narrowed the alert coverage to a tiny sliver, barely half a mile from the runway. Nobody at the facility asked for help. Nobody at headquarters noticed. Everyone assumed MSAW was working because, on paper, it had been deployed. The fix didn't come from outside consultants or a task force. It came from 2 career FAA veterans who had spent decades inside the exact systems now under scrutiny, and a team of field experts who understood the software and terrain mapping details better than almost anyone. Brian Reel got his electronics training in the Navy. When he finished basic training, he was offered radar school in Milwaukee or sonar school in Key West. As he'd later tell it, he didn't even know what sonar was, but he knew where Key West was, and he wasn't spending the winter in Milwaukee. After the Navy, he worked on IBM mainframes, Navy tactical data systems, and served as computer supervisor on Apollo tracking stations right there on Guam for missions 1 through 14. He installed the original ARTS-3 radar automation systems for UNIVAC at some of the country's busiest airports and worked as a radar technician on Guam in the late 70s. By 1997, he was division manager of terminal automation engineering at the FAA Technical Center, responsible for every piece of terminal automation hardware and software in the country. The specialists under him were the ones who helped field facilities maintain the terrain maps that made MSAW work. Tom Howell started as a controller in 1967, working oceanic, domestic, and radar positions before moving up through supervisor, data systems officer, area manager, regional staff, and eventually air traffic manager of Cleveland Center. He'd served as acting deputy director of the newly formed AOS organization, which provided engineering support to some 78,000 FAA facilities, and later ran the en route counterpart to Brian's shop. Together, Brian and Tom had over 60 years of combined hands-on experience with the exact radar, computer, and software environments MSAW lived inside. They'd watched the finger-pointing between air traffic software people and airway facilities maintainers. They'd lived through the rushed, congressionally pressured deployments that left systems half-tested. They knew where the bodies were buried, because in many cases, they'd been there when it happened. When news of the crash broke, the FAA's senior leadership got on a late-night conference call. The tone was urgent and defensive. Before the facts were even fully known, people were already looking for someone to blame. A local technician, a controller, someone close enough to the ground to absorb the weight. Then Brian spoke. By pay grade, he was one of the most junior people on that call. But he carried something far more valuable, decades of hands-on experience with the exact systems now under scrutiny. His voice was steady, measured, no emotion, no hesitation. The narrative, he said, was wrong. He told the deputy administrator he could prove it, and offered to fax the documentation right then. The kind of silence that settles over a room when senior leaders realize the conversation has just shifted beneath them. Then, Monty Belger, acting deputy administrator, spoke. "Fax it to me." A few days later, Stan Rivers, the service director for airway facilities, sat down with Brian and Tom. The urgency wasn't theoretical anymore. The problem was clear. So were the stakes. Rivers didn't waste words. He'd just stepped into a new reality, responsibility for both hardware and software under the Airways Facility Service. The old turf battles, the us versus them mindset that had let problems slip through the cracks, he knew that had to end. Not if this was going to be fixed for real. He looked at them and said the closest thing the federal government ever offers to a blank check: whatever you need. No qualifiers, no hedging, no committee language, just trust and expectation. It was a line in the sand. From that point forward, this wasn't about patching a system. It was about rebuilding it so it could be trusted again. Within days, Tom and Brian put together a team. 5 of the best field data systems specialists in the country, plus a senior specialist from the technical center. These weren't desk-bound managers. They were the people who actually wrote the adaptation code, built the terrain maps, and flight-checked the results. They were brought to the technical center, handed the complete national MSAW library, and turned loose. What they found was sobering, though not surprising to the 2 veterans. Guam wasn't an isolated case. Dozens of facilities, major terminals, and en route centers alike had quietly adjusted the system to reduce nuisance alarms. Thresholds had been moved. Terrain maps had been simplified. In some cases, entire monitoring volumes had been shut off. The team rebuilt every site's configuration from scratch, using standardized national parameters. They shipped the corrected packages back to the field and stood shoulder to shoulder with local crews during installation. To rebuild trust, they invited NTSB technical staff to embed with the team. Full transparency, no closed doors. The NTSB observers watched every step and later told Brian and Tom they'd never seen the FAA open the curtain that wide. Flight standards was looped in. MSAW verification became part of every routine airport flight check, on a 2-year rotation to keep the system honest. The air traffic controller involved sat quietly in the audience at the NTSB hearing, just another face in the room. Then the truth began to unfold. As investigators walked through what had gone wrong, detailing the flaw and the fix, he broke. He wept openly. The weight of years finally catching up. For too long he had worked with a system that cried wolf, false alarms, day after day that taught him not to trust what he saw. Eventually he'd come to believe the system just didn't work. And when it mattered most, that belief followed him. The burden he'd been carrying was crushing, and it was never his to bear. When Tom took the stand, he didn't hide behind jargon or bureaucratic language. He spoke plainly enough for anyone in the room to follow. He explained what MSAW was, what the flaw was, and what had been done to fix it. Then he went further. He told the board this wouldn't happen again, not like this. All L configurations, he said, would now be managed nationally at the FAA Technical Center in New Jersey. No more fragmented fixes, no more silent gaps. And then he drew the line that mattered most. This was not a personal failure. It was systemic. Carl Schellenberg, serving as acting air traffic service director, stood with the team. Even as pressure built behind the scenes, voices urging that Tom or Brian be reined in to limit the fallout, he refused to retreat. Truth, not optics, would carry the day. In the end, it did. The NTSB chairman would later call the FAA's response a model, an example of how the agency and the board were meant to work together when everything was on the line. But for those in the room, the moment that stayed with them wasn't the commendation. It was the sound of a man finally released from a weight he was never meant to carry. A few days after the hearing, Brian and Tom flew to Guam. There was no ceremony waiting, just unfinished business. They made their way up Nimitz Hill, the path quiet except for their footsteps. Scattered around them were fragments, twisted metal, remnants of a plane that should never have been lost, pieces of a failure that had been invisible for years, until it wasn't. They reached the top and sat down. No speeches, no analysis, no need to explain what they both already knew. For 2 hours, they said nothing. These were men who had spent their careers building and maintaining systems no one ever sees. Silent safety nets designed to catch the unthinkable. Systems that had worked thousands of times, until the one time they didn't. And that one time changes everything. The wind moved across the hill. The silence held. This wasn't about blame anymore. That had been settled. This was about responsibility. 2 engineers, sitting among the wreckage, carrying what had happened, and the unspoken resolve that it would never happen this way again. The work took nearly a year. It wasn't cheap. It demanded time, money, and a level of scrutiny the system had never faced before. Every assumption was challenged, every configuration questioned, nothing left to chance. And when it was done, the result was both simple and permanent. Every MSAW installation across the National Airspace System was brought into alignment, properly configured, rigorously verified, placed under national management. No more patchwork, no more quiet inconsistencies hiding in the margins. The nuisance alarms, the ones that had eroded trust for years, were reduced, but the safety net stayed intact, stronger, not softer. Controllers started trusting the system again, and perhaps most importantly, the system became harder to dismiss, harder to work around, harder to ignore when it mattered most. No headlines marked the moment, but from that point on, the margin for error got a little smaller, and the margin for safety got a little stronger. No similar MSAW-related controlled flight into terrain accident has occurred in the United States since. That isn't luck, it's legacy. The direct result of a small group of deeply experienced professionals, Brian, Tom, the field specialists, and the leaders who gave them the authority to act, who refused to look away. They refused to treat a broken safety system as someone else's problem. They didn't bury it under process and politics. They owned it, and then they fixed it. Not for recognition, not for credit, but because that's what professionals do when the stakes are measured in human lives. Quietly, without fanfare, they changed the system. And in doing so, they changed the outcome of events that would never make the news, because they would never happen at all.